Geological Perspective for Low Resistivity Pays. Low resistivity pays have been logged in wells throughout the world. They have been found in clastic basin regions, ranging from fields off the coast of Brazil to the Gulf of Mexico, the North Sea, West Africa, Indonesia, and Alaska. While most of these pay zones meet a criteria best characterized as low resistivity zones, that is, having a deep resistivity ranging from 0.5 to 5 ohm meters, other pay zones can be characterized as low contrast zones. While these two terms are sometimes used interchangeably, low contrast pays are distinctly different from low resistivity pays. Low contrast pay exhibits a very small difference in resistivity readings between the pay zones and adjacent shales or wet zones. This condition is commonly found when the resistivity tool encounters pay that is adjacent to a zone containing waters of low salinity content. As we zoom into a microscopic scale, we can see that a decrease in salinity causes the electrical pathways through the water to become weaker and more dispersed, thus causing the water to become less conductive, or conversely, more resistive. Therefore, while the resistivity of the pay zone might not be low, the resistivity of the adjacent water leg is high enough to make it hard to distinguish between the pay and wet zones. Now, let's move from low contrast pay to low resistivity pay. Low resistivity pay is characterized by deep resistivity log curves that read between 0.5 to 5 ohm meters. This can be attributed to a variety of geological factors that act to confound the logging tool. Bed thickness. Some pay zones are simply too thin to be resolved by the logging tool. Thus, high resistivity pay zones are averaged with lower readings from the adjacent beds. Grain size. Very fine grains can lead to high irreducible water saturation and thus lower resistivity readings. Clay distribution. Classified as either dispersed, structural, or laminated. All are capable of holding non-producible bound water that will reduce the resistivity of the pay zone. Mineralogy. Conductive minerals, such as pyrite, glauconite, hematite, or graphite, will also lead to lower resistivity. Water salinity. As salinity of the interstitial water increases, the resistivity within the pay zone is reduced. Of these factors, probably the most common cause of low resistivity pay is a simple combination of thin beds containing highly conductive shales and their associated bound water, along with thin pay sands that are below the vertical resolution of the logging tool. Though low contrast and low resistivity make it hard to discern the presence of pay on some logs, these zones tend to be very productive when discovered, and so you must consider the entire range of factors that might influence log responses. For additional details on low contrast and low resistivity zones, consult the sections in IPIMS that cover the geological perspective and the role of clays and shales.